Okay, so I've said that this understanding transportation markets will help us do better planning. We've kind of finished the description of the types of networks that exist, the operations. We've done some studies of fixed and variable costs, indicators based on the rates, and doing analysis. Now we're going to lead to how do we use this kind of information for better planning. So the first exercise in transportation planning is a simulation of a response to an earthquake. The scenario is this. Mountainland suffered a major earthquake 3 days ago. 8 organizations have already begun bringing in cargo. There's cold conditions. The villages are difficult to reach. It's mountainous. And given that it's cold, shelter is now a priority item. However, health, water and sanitation, and food are also important commodities at this time. Here's the initial state of Mountainland. So most of the goods are flying into Mammoth, which is the major seaport. They are then able to move on the Green Line, which is a fairly good road, by large truck. And you currently have 2 large trucks in Mammoth to do that. In Attitash, you have smaller trucks. These smaller trucks can move on the orange lines. And finally, you have 1 helicopter. The only access to 3 of the affected communities is by helicopter. This is the operational network on what can move between the different locations. And the trucks, the vehicles that can move across them, how long they take, and then how much they cost per ton. Your task is simple. You have to make a transportation plan for the next 4 days. In making this plan, you simply have to determine which vehicles go where with what cargo.
Total weight.
We're talking about the total weight. For a large truck, we have 40 metric ton. We can do 1 truck.
It has to come back. This one has to come back and drop and come back. So yeah.
Can we put it on a small truck?
Only one truck.
It's only 1 truck. It's fine, I guess. Yeah, they can go the same
We
way
are
because
on
there are
this.
2 trucks.
We are on
This truck is carrying 40 tons, right? And there are three small trucks here. Each of them is taking 10. So as one truck comes, we give it 10, then they all go. Okay?
From Attitash to Goentzel, 1 request, Attitash to Goentzel, 2 requests, and we have from Mammoth to Clinton. So now we can move our big truck. He will come at Attitash, he will load shelter from here and bring everything together to Clinton.
If you are intervening in an emergency, you don't just hand all the shelters. What will they eat?
Response priority, that's it.
No, that's okay, but to see the
Just this. So you said that first, all shelter. Secondly, you said all health. And third, if you said all, I don't know.
But we are logistic. We have to make sure that we are using resources efficiently.
You have to go to Attitash. This is the only place that this truck can go.
But we still need to put the movement
This
from
truck has to be
Attitash.
turned.
Yeah, it has to be
Turn it,
turned.
turn it.
Attitash to Mammoth.
That's why I say that chopper can do 3 rotations to maximize, so it will be 9 tons. We'll be remaining only with 1 ton.
You're right.
So one day we can clear 1 truck. Next day we clear another truck.